If you know your tech history, you've probably heard the story of the legendary 1956 Dartmouth Summer Research Project. It's widely celebrated as the official birthplace of artificial intelligence. But, the reality of what actually happened during those weeks is far more complex, a bit chaotic, and honestly, way more fascinating than the neat and tidy myth we usually hear. So let's dive into the true story in this explainer. Okay, let's kick this off with a bit of a mystery. In July of 1956, a woman named Louise wrote this exact letter to her boyfriend, a brilliant young scientist named Ray Solomonoff. She was basically asking, what on earth are you and Marvin Minsky actually doing up in New Hampshire for the summer? I mean, Marvin's wife, Gloria, was completely in the dark too. Well, it turns out Ray and Marvin were at Dartmouth College casually trying to invent an entirely new scientific discipline. Section 1. A mysterious new science. To really grasp what they were up to, we first have to understand the era they were operating in. This was a time of a massive post-war technological boom, and people were getting obsessed with the idea of thinking machines. Just look at these 1950s science fiction magazines. They had completely primed the public for a future filled with robots and androids. But within the actual scientific community, it was totally the Wild West. Scientists couldn't even agree on what to call this emerging field. Some were calling it cybernetics, others automata theory, or even complex information processing. There was brilliant work happening, for sure, but it was scattered all over the place, lacking any unified direction or even a shared vocabulary. Section 2. Planning the Dartmouth Project. So amidst all this confusion, as they began planning for the summer, a young, visionary math professor at Dartmouth named John McCarthy decided it was time to finally forge a new direction and bring everyone together. McCarthy brilliantly coined a completely neutral term, artificial intelligence. He specifically chose this so he wouldn't step on the toes of the cybernetics crowd. He drafted a proposal to the Rockefeller Foundation and sent out invitations, like this actual letter right here to Ray Solomonoff. And the pitch was incredibly ambitious. He wanted a 2-month summer summit with 10 brilliant minds to essentially figure out how to make a machine simulate every single aspect of human intelligence. No big deal, right? Section 3. The reality of summer. But, as you can probably guess, the grand, highly organized vision laid out in that funding proposal very quickly collided with the reality of a super disorganized summer. So we really need to separate the myth from the reality here. The myth paints this picture of 10 scientists locked in a room, collaborating deeply on a single breakthrough project for a solid 2 months. But the reality? It was much more like a disorganized summer camp. People had other commitments. There was this loose flow of visitors popping in and out for just a few days. You had massive egos clashing, and ultimately only 3 people, John McCarthy, Marvin Minsky, and Ray Solomonoff, actually stuck around for the full 8 weeks. And the daily rhythm wasn't exactly a high-pressure lab environment either. A lot of the transient participants stayed right here at the Hanover Inn. Their days consisted of loose discussions, afternoon teas, and get this, even Gloria Minsky's part beagle dog Senjay would sit in on the commute to the campus. It was informal, highly conversational, and incredibly unstructured. They completely took over the top floor of the Dartmouth Maths department. Because they were essentially inventing a field from scratch, they spent a massive amount of time just debating definitions. I mean, they literally spent an entire afternoon looking up the word heuristic in this exact massive dictionary that was left behind in the room. They were just desperately trying to find a common language. But despite the casual vibe, real foundational work was happening. You can see it in these incredible handwritten sketches from Ray Solomonoff and Trenchard Moore. They were capturing a presentation by Ross Ashby on his homeostat machine, which was this electromechanical device that could adapt to a changing environment. They were rigorously debating the limits of these early machines, specifically how long it would take them to search for actual solutions. Now, at the end of the summer, Ray Solomonoff jotted down this brutally honest, almost lukewarm review of the whole project. He noted that he got his report printed, met some interesting people, but also realized, quote, how poor most thought in this field is. Ouch. They absolutely did not build a thinking machine. They didn't even agree on a group project. But the true legacy of the summer wasn't a single invention. It was that the project birthed 3 massive ideological splits that would literally define the next 70 years of AI. Section 4. The shift to symbols. This was the first major ideological split to come out of those rooms in Dartmouth, a foundational move away from mimicking the physical brain and toward processing abstract symbols. See, before 1956, the dominant approach was cybernetics and brain modeling. Researchers were trying to literally simulate biological neurons and analog feedback loops. But at Dartmouth, attendees like Alan Newell, Simon, and Ray Solomonoff championed a totally new paradigm: symbolic processing. They argued that intelligence wasn't about squishy biology. It was about processing symbol structures using heuristic rules. It was a massive, massive pivot from hardware-focused brain mimicking to software-focused logic. And we know this pivot happened in real time, right there. Marvin Minsky came to Dartmouth deeply invested in neural networks, but after spending the summer reviewing Ray Solomonoff's early ideas on symbolic inductive inference, Minsky completely abandoned his neural network approach. He went all in on symbolic logic. And this shift established symbolic processing as the absolute dominant force in AI for decades to come. Section 5. Deep versus shallow methods. The second huge fork in the road was a fierce battle over what kinds of problems AI should actually try to solve in the first place. This was the great debate between shallow and general versus deep and specific. Ray fiercely advocated for a general approach. He wanted machines to work lightly on a massive variety of everyday problems to learn general common sense. But pretty much everyone else, like Minsky and Arthur Samuel, wanted to go deep. They wanted to build machines that mastered highly specific, limited domains, like a machine that exclusively proves geometry theorems, or a program strictly designed to play checkers. So why did the deep and specific crowd win out? Well, it largely came down to what's known as the demo to sponsor problem. To secure ongoing funding from places like the Rockefeller Foundation or leader the military, you couldn't just promise vague common sense years down the line. You needed flashy, concrete demonstrations. A computer beating a human at checkers? That is a fantastic demo. This pressure to prove immediate utility permanently pushed AI towards specialized expert systems. And honestly, it's an issue that still heavily influences the tech industry today. Section 6. Deduction versus induction. This brings us to how machines actually reason, which was the final, and frankly, probably the most consequential ideological split of that entire summer. The attendees were fundamentally torn on how a machine should think. On one side, you had deductive reasoning, drawing strictly valid conclusions from assumed premises using hard, fast rules. John McCarthy was a huge fan of this. But on the other side was inductive reasoning, looking at massive amounts of past data and observations to predict the future using probabilities. In this debate, Ray Solomonoff stood almost entirely alone. While everyone else was busy building hard-coded deductive rules for specific games, Ray was writing a 175-page paper on probabilistic induction. He was dreaming of a machine that didn't just blindly follow rules, but actually learned from historical examples to predict future outcomes. At the time, McCarthy and the others thought probabilistic methods would require way too much computing power. They basically thought Ray was chasing a ghost. And here is the ultimate irony of the Dartmouth summer. For decades, the AI industry followed the path of the majority: specialized tasks, expert systems, and rigid deductive logic. But when you look at the generative AI models completely dominating the world right now, systems that ingest massive amounts of data to probabilistically predict the next word or image, you realize they aren't using rigid deductive rules at all. They are doing exactly what Ray Solomonoff proposed back in 1956. So, knowing how artificial intelligence has ultimately evolved, we have to ask, was the guy standing all by himself in the corner of the Dartmouth Math Department right all along?